Hey guys, this is going to be a quick tutorial on how to linearize data. So let's say we had an x that was 1, 2, 3, 4, 5. We'll just keep it simple. And we had some y values that were our x squared, but let's say we times it by 5. So equals 5 times whatever's inside of our x squared. So for the first one, 1 squared is 1 times 5 is 5. For our second one, 2 squared is 4 times 5 is 20. So it looks like it's checking out. And I'll fill up the rest here. So what we have here is our x, and then 5x squared. So that equation would look something like y is equal to 5x squared. So that's what we're working with. I want to graph this stuff. So insert, chart, we want to scatter, and let's just customize a couple things just to make it a little easier to read. Let's go to our verticals, 0. Okay, and here's the interesting part. If I then want to get a trend line, which we very typically want to do in this class, we'll see that it doesn't really go through the data too well. And in turn, if I were to derive an equation from this line, it wouldn't be that helpful. It doesn't seem to really fit the points too well. This is where linearization comes in. We can take that data and make it a line instead. Instead of being that curve, we could make it a line. So to me, just based on my experience, and we're going to gain this intuition with time, I'm seeing this curve here. So I'm thinking that this might be an x squared relationship. And kind of cheating, we already know it's an x squared relationship. So to linearize, we're going to graph it x squared versus y. So that means we want to use the exact same y values. Oopsie. Undo that. I'll just do 5, 20, 45, 80, 125. So I'm using the same y values. But now, instead of using 1, 2, 3, 4, 5 for our x, we're going to graph x squared. So 1, actually I'll write a function, make my life a little easier. So I want to do 1 squared. So it should be 1, 4, 9, 16, 25, and checks out. So we have this now instead. So if we want to think about it, our equation is kind of like, well, it's still the same, but instead of being x squared, you can almost think of that as being just an x, but we're replacing that x with squared. Seems a little weird, but we'll see what our graph looks like. So if we take this, insert a chart, same as before, we're going to want to scatter plot, customize, 0, vertical 0, and we look at it now. Look at that data. It's a straight line now. So if we were to get our trend line, look how perfectly it goes through the data. Now, this has a lot more meaning that we can extract. We have this slope here of 5 that if this were some sort of lab that we were trying to model what was going on, this is going to give us a lot more understanding than this line up here, which seems to be very off. So if we see these parabolic relationships, we can graph it x squared versus y, turn it into a line, and thus get more data from it. Let's do another example. Instead of it being a squared relationship, let's look at a 1 over x relationship. So let's again say we had 1, 2, 3, 4, 5. And let's do, I'm going to write a function, I'm going to say 2 times 1 divided by whatever's in my x column. There. So here we have 1 divided by 1 times 2, so we have 2. Here it's going to be 1 divided by 2 times 2, so it should be 1, so on and so forth. Okay. And if we decide to graph this as a scatter plot, let's see what we see. Okay. Again, this is not looking too good for us. Try to do a trend line. That's not going through the data very well. That's not going to give us an equation that's going to be very useful to us. That doesn't tell us much because this line is clearly not on that data. So, since we want to continue working with lines, we have to make this data align somehow. And as we gain intuition, we'll start to understand what the shapes usually tend to be. When you see this downward sloping line, that's a big indicator to me that we might have a 1 over x relationship. So, over here, I'm going to graph 1 over x versus y. And this is going to hopefully adjust this curve so that it becomes a line. So I'm going to take what I have up here, 1 divided by that value, and there we go. That's just whatever's here. 1 divided by 2, 0.5, 1 divided by 3, 0.3, 1 divided by 4 is 0.25, and so on and so forth. I don't need this last column. I don't know why it's here. Okay, and then over here, I'm just going to put exactly the same thing that we had before. That's key. You don't want to adjust things. You want to do exactly what you had before for your y. We're only changing our x to fix this up. So if we decide to graph this, we're going to get something like this. So we have our y values to 0.6, 0.5, 0.4 over here. Same values over here on the x. We're going to just clean this up. Set our zeros. Okie dokie. And as we can see already, we have much more of a line. We get a trend line, goes perfectly through the data, and most importantly, if we get an equation, that's going to tell us a lot of useful information, especially the slope of 2, which in this case we expected. So that's the gist of it. We're modifying our curved lines into straight lines by playing around with our graphs and getting them to look like this. Sometimes we can have more complicated examples where we have to do a double linearization, and those are some examples we'll be seeing in class.